welcome everybody. Thank you for joining us. What I expect to be a very interesting topic. Before we get underway, let me quickly introduce myself. I'm the person on the right there. So my name's Jonathan Gordon. I'm the directing analyst with TP Research, and I'm an industry analyst who's rather enthusiastic about industrial cybersecurity. And I spend my days, some evenings, I guess the occasional weekend, exploring, learning, discussing, and strategizing of the best way to secure industrial enterprises. I've authored various reports, research reports and guides covering the OT in industrial cybersecurity market, the technology, the services and the vendors therein. And I guess I'm just continually fascinated by the passion and sometimes the clash of people and processes and technology and I guess cultures in this space. So for me, cybersecurity is all about identifying and managing risk, and in particular, understanding how in these operational environments we're going to discuss today, how they're vulnerable and taking action to manage and reduce the risk to them. So Roman, would you like to introduce yourself?
Yes, thank you, Jonathan. Always great talking with you. So my name is Roman Arutunov. I'm a co-founder at Xage Security, heading up products. My background is really a combination of cybersecurity and industrial networking. So I spent a number of years doing malware protection and data security at Symantec, and then also quite some time running an industrial networking business at ABB, where we really provided networking solutions for millions of operational assets, right, across energy, manufacturing, transportation, even defense verticals. And so after doing that for a number of years, decided to jump out and start Xage all around protection, cybersecurity protection for these networked industrial operations. Looking forward to this webinar, Jonathan.
Likewise, absolutely. So let's take a look at the agenda for today. We're going to quickly cover the current market landscape, talk about some key drivers and reactions to some of the changes that we're seeing and we're living through. And zero trust, as most of you would know, is not a specific product or solution. It's rather a way of thinking, a group of concepts or an approach, and not everyone defines zero trust in the same way. So it's key to understand exactly the approach that we'll be discussing today, and perhaps how that differs from others using the term. And Roman will later walk us through Xage's approach. Then for me, perhaps the most interesting section, Roman will highlight a couple of customer case studies so we can see and understand exactly how Xage's technology was deployed. And I guess more importantly, the impact on those companies' cybersecurity posture and their residual risk. And we expect to leave ample time for the Q&A session towards the end. So just a point of housekeeping before we get started. If anyone does have a question, there's a Q&A button down the bottom, or a chat button. Be sure and submit your questions there, and we will do our very best to respond to everyone through the webinar or towards the end. So I think we're good to get started. So let's see. It's an interesting picture where to start. The last 12 or 24 months has been tremendously tumultuous for our industry. COVID-19 was a game changer for many, not all, I have to say, but many, most industrial enterprises were woefully underprepared for this type of occurrence. And if you recall, in the early days of the pandemic, we saw teams of engineering and operations people literally sequestered on site in plants and factories, in operation rooms. And this was a situation that really couldn't, stay afloat for very long, had a limited shelf life. And the next step for many companies was figuring out how to connect everyone remotely, people working from home or from outside the operational environments. There was still a great need to access and support and make updates and look what was going on in these networks and the devices that were connected to them. And the need to react quickly to the situation often meant that security was, I guess, in some cases thrown under the bus. Or maybe better to say that some security holes were open rather than closed. And I think many of us are still dealing with some of those issues. If we add to that another unforeseen situation by many, a war in Europe in our lifetime, the invasion of Ukraine, had a significant increase on both the level of concern and the activity around protecting critical and other infrastructure from cyber threats. Right? We saw how cyber war threats and malicious actors were operating on site, literally physical war on the ground. And if anything, it demonstrated how intertwined those worlds are, the physical and the cyber, and the world economies, and I guess really how susceptible the global supply chains are. And if we take a step back and look at the wider market, there's been no lack of high-profile attacks. Every time I do these things, it just becomes easier and easier, unfortunately, to highlight the type of attacks from energy, water, gas, pipelines, transportation, right? Names like Colonial Pipeline, Ultima, JBS, NHS, DESFA not too long ago. Just last week, a UK transport company was hit. The list literally keeps growing as we watch. And there was a UK water supply company that was hit, allegedly breached by the Russian-based Clop ransomware hacker group. And while details are still emerging, what we've seen so far, it's not a pretty picture. So all in all, there's a clear and present danger facing asset owners and operators. And for anyone following the market, even at a distance, it seems that the vulnerabilities that are being uncovered and reported are literally happening every day. And in our corner of the industry, it seems like malicious actors don't need to bother with zero-day attacks. There are just so many forever day attacks to exploit. So in short, in many ways, we're just making it too easy for these people. And many of the successful attacks, or the ones that we know about, have simply been due to a lack of very basic cyber hygiene. So yes, I have painted a rather bleak picture, but there is a silver lining. I think there are some positives that come out of this. The conversation that we're having today and the conversations around the sort of industrial cybersecurity world have increased dramatically as a result of a lot of these high-profile attacks and incidents. And the industry as a whole, governments and industrial bodies and enterprises are all reacting. So I think that's the one positive we can take away. Obviously, there's a lot of work still to be done. When we look around the world, we can see that legislators and regulators are rolling up their sleeves. Governments around the world are starting to move. Things like the US presidential order caused a flurry of activity. It wasn't all well directed, but well intended, and then nevertheless, it had a huge impact on the interest in the conversations in the space, right? Things like the TSA pipeline directive, which we'll talk about a bit later. Singapore recently updated and republished its cybersecurity code of practices, focusing on critical infrastructure and information sharing. That came into effect literally a month or two ago. My home country of Australia mandated registration and reporting of critical infrastructure assets and incidents likewise. And similarly, in the US, CISA has been developing regulations following the cyber incident reporting for critical infrastructure, which is an act I think was signed into law by President Biden earlier this year, March or April. And of course, the EU, the NIS2 directive, which is aligning more people and explaining what measures need to be taken to increase security in Europe. So there is movement. That's the good news. We have endless frameworks around this space as well. Obviously, the IEC 62443, the NIST 802.82, the MITRE ATT&CK for ICS, the list goes on and on. Perhaps too long. We might need some consolidation, but that's a different topic. And another piece of good news is some of the collaboration that's being driven, information sharing that's starting to happen between the private sectors and the public sectors. In the US, particular MITRE, the Department of Energy, we have CISA's ICS certs and the JCDC and other collaborations underway as well. So there is good news. Now, I don't think any sane person believes that we can regulate our way out of this challenge or problem. But it is driving the conversation and driving interest and in some cases driving action as well. So there are some positive outcomes. You'll notice that this slide actually has two titles. I wasn't sure which one to choose, but so I left the decision up to the audience. And I often say that in industrial cybersecurity, the challenge is really more about people and processes. It's really about the culture and then the technology. And anyone approaching this area needs to be cleanly aware of the different and sometimes, I guess, very opposing views that professionals involved in operating and securing these environments. So for engineers, we know are very concerned with the safe operation and continued production, right? They're all about keeping the lights on, the gas flowing, and getting the services to customers. And any solution or product or approach must keep this top of mind, right? OT networks can't be simply halted for patching or reconfigured or re-architected. And vendors designing solutions and service providers helping on the ground, and even the teams, right? The collaborative teams within the organization need to keep this need to take this into account long before they step anywhere near the production floor. And finally, when we take a look at some of these enterprises and everything that we've mentioned so far, it's clear that the industrial cybersecurity paradigm is changing. Enterprises and the executives that run them, the shareholders that own them and the boards that represent them, they're facing an incredibly complex challenge that we can see is just getting harder and harder. Any breach could have a significant impact on the company, on the environment, on the directors themselves, right? So the company directors are feeling the heat. Many of them are could be personally liable for the consequences. So the ground is literally shifting under their feet. And for example, the insurance companies, it seems like they're beating the retreat. Just last month, I read that Lloyd's of London, obviously a name that's well recognized, they announced that they're going to require their underwriters to exclude coverage for state-backed cybersecurity attacks that are linked to war, I guess as a result of what's happening in the Ukraine. They mentioned just that the potential losses greatly exceed the ability of the insurance market to absorb that. They just don't have the money to cover those type of losses. Nor do they particularly have a good understanding of the risks involved, but that may be a topic for a different webinar. So those type of directives are due to come in early next month. So the whole concept of transferring risk and using cyber security insurance is maybe taken off the table, which is a backup plan for many of us. It's important to keep in mind that cybersecurity is essentially a business risk, right? We need to address and mitigate those risks And we need tools and processes that will not only enable you to see and understand the current picture, but we need tools that will help you change that picture and affect the outcome. And up until recently, vendors in this, I must admit, very nascent space have been focused on providing the visibility and asset inventory, showing asset owners and operators exactly what's on their networks. And while many of these enterprises have deployed solutions around visibility, still more have yet to do so. And our take on that is they're simply waiting for more value. There's a big difference between being able to detect and visualize, which is a great starting point, but we really need those tools that can actually change the outcome. So going from really detection to protection, proactively mitigating some of these risks, and at the same time providing transparency to stakeholders, to management, to board. So we need to start going beyond visibility and looking how we can secure these industrial enterprises and environments end to end. It's really about reducing the risks and strengthening the resilience of the industries. And that's no easy task. And Roman's going to help us walk through that shortly. Moving beyond visibility is really where the hard work begins. So identifying the business critical process, understanding them, segmenting them, measuring the risk, understanding the risk, even implementing basic cyber hygiene, as we've seen, can be really tough. But having said that, Roman is going to help us and walk us through some of the solutions around this space.
Thank you, Jonathan, for giving us that introduction and setting it up for me. So protecting today's operations is actually quite a difficult task, right? Today's approach to cyber protection really consists of this patchwork of point solutions and disjoint access methods. It is way too trusting, fragmented, and complex to use, and actually also complex to manage. What happens is we set up these wide trust-based access to segments. There may be a few segments in an operation, and they're just set way too wide. And a segment means anything inside of that segment has access to everything. Oftentimes it's not even clear what's in the segment or what should be in the segment. And these segments can have thousands and thousands of assets. We use password management tools to manage credentials on assets, but majority of assets we want to protect, like PLCs and RTUs. In fact, over 80% of them effectively don't have credentials. So these password management tools are really ineffective. We use firewalls to really block access, but then we need to facilitate access too. So we start using firewalls to allow access, which is not what they're designed to do. And in order to protect that, we started using concepts like jump boxes. And jump boxes are nothing more than RDP servers, and RDP protocols are vulnerable themselves and often are attack vectors. So separation using jump boxes leads to more and more attacks. And then finally, we use things like VPNs, and VPNs put assets, remote endpoints directly into networks and are often attack vectors themselves. So it's a challenging undertaking, and today's patchwork of fragmented solutions is really not meeting the needs of today's operations. So a different approach was needed, and a more comprehensive approach that brings together visibility and protection. So this new approach that Xage actually embraced is what's called an asset-centric security approach. It really focuses on an asset instead of the network itself. Network-based protections are really concerned about protecting the network perimeter, not necessarily the asset itself. In fact, many times operators don't even know what assets are within their networks and how they're interacting. This is a diagram for one of our deployments. You can see there's just way too many interactions, unnecessary interactions with assets. An approach that focuses on protecting an asset would just allow the necessary interactions, and there'll just be a few of them. So asset-centric approach really brings together visibility and protection. It delivers discovery for various assets. It delivers interaction visibility, granular access management, identity-based segmentation, and risk management, all around an asset. And an asset, you can think about an asset, any asset having an identity itself. So really an asset-centric approach leads to zero trust. Zero trust that's centered around an identity of an asset, identity of the user, even identity of the data itself. And that's enforced across the entire operation, remote operational sites, the control centers, the DMZs, the enterprise, and the cloud services themselves. A comprehensive approach that brings together visibility to protection around an asset identity itself. So it streamlines the way we look at things. It narrows down the attack surface dramatically, controls various interactions per policy, and protects those assets. So zero trust has actually been discussed in an operational space for a while now. I've done a number of webinars on zero trust itself. So we've decided to go out there and see how well operational folks, we looked at director level and above, have embraced zero trust. And some interesting findings came out of this survey. We really focused on critical infrastructure industries. So these were energy firms, manufacturing firms, transportation as well. First of all, 61% of the respondents recognized that reactive strategies are no longer enough, or not actually enough, to prevent attacks. So moving beyond just detection. And 88% of them have actually already taken steps to adopt zero trust. So they've determined that they've created zero trust strategy and are now working either on a specific plan to execute on that strategy, or actually have a project that they're executing on already. Another interesting finding is that 58% of them have found ways to adopt zero trust without impacting current assets. Another big misconception that exists in the market is that zero trust means rip and replace all your assets. Some of them may be legacy assets, flatten out your networks, and it's a big re-architecture project. Well, it's not exactly so. Many of them have found, majority of them have found ways to adopt zero trust with existing assets over existing multi-layer defense and depth networks. So what do we mean by zero trust, and how does Xage look at it? So Xage really looks at zero trust as an identity-based approach, taking into account identity of really anything, an identity of a user, application, machine, or data itself. We actually go out there and we fingerprint all the various assets and interactions that exist, and then create a policy around a specific identity. So with us, there's no reliance on implicit trust zones, static accounts, or firewall rules. Everything is dynamic. All the access policies are around an identity itself. All the protection policies all are based on the identity itself. It's all the interactions are created just in time and just with just enough access. So meaning that access is granted only when it's needed and for the duration of time that it's needed. And it's role-based only for specific tasks based on various roles. It applies to both north-south, so remote, and down into the actual operational assets like PLCs and RTUs, as well as east-west, so within a site and across sites. The zero trust approach that we've created applies directly to multi-layer networks. So you can set up a granular access policy to individual asset and have it go across multiple layers with protocol terminations and session breaks per the various multi-layer defense policies that may exist, actually utilizing multiple authentication methods and multiple layered on top of each other as well. So all of this can be created in a centralized way and distributed across the entire operation. So giving the operator the ability to manage all the policies centrally and then enforce all the various interactions in a distributed way across the remote sites, control centers, the enterprise itself, cloud services if there are some. Perhaps the biggest benefit here is that there are no agents, no clients, and no network changes to deploy the Xage solution. It overlays directly on top of the existing assets and networks. So let's dive a little bit deeper. Already starting to alluding to this, but Xage deploys as a way to really identify and protect assets to control interactions and to really protect data itself as well. We provide a zero trust remote and local access management solution, a segmentation solution, asset visibility, threat management, and data security solution, all under a single umbrella that we call this Xage Fabric. When the Xage Fabric is first deployed, it goes out there and discovers all the various assets. It visualizes the interactions that those assets may be having and helps operators identify critical systems. It then fingerprints all the various assets, really the applications, the machines, devices, to create a unique identity for each. We can then allow the operators to create policies utilizing both role-based as well as attribute-based approaches to control interactions. And I mean the interactions both user to machine as well as machine to machine interactions and app to machine interactions. The Fabric node deploys as these virtual machines. They're called the Fabric nodes. We also have an appliance called the Xage Enforcement Point and a policy manager that really manages all the various policies for the interactions. The Fabric deploys, it can be deployed at the various levels in the operations, DMZs, enterprises, in the cloud, creates an overall mesh architecture. And each Fabric node acts as an authentication, authorization, and enforcement point to strictly enforce policies, access policies wherever they happen. So whether they're happening at the edge or coming in from the remote location or from the cloud, interaction policies are enforced in a consistent way across the whole entire architecture. The architecture that's utilized here is it's what we call a distributed mesh architecture. The benefits of that, there's no single point of failure or compromise, and the policies are enforced in a very consistent way. I mentioned this concept that it deploys as an overlay already, right? So it deploys on top of existing assets and networks and creates an overlay path for interactions. So all nodes, they create these reverse tunnels with each other from more trusted areas to less trusted areas. So with that, between the fabric nodes and the tunnels, all the authentication and enforcement of policies is done within the fabric. All the interactions are filtered within the fabric itself. So this means that there's no need to manage firewalls. We've seen customers remove remove a number of firewalls, and also, more importantly, simplify rule management on many of these firewalls. We've seen firewalls with millions of rules out there, and taking weeks, 6+ weeks to add a rule. With us, most of those rules go away. And all of the enforcement and filtering is done within the fabric itself on per identity basis and dynamically, right? The fabric also manages credentials, right? So it's important to rotate credentials on assets and that have them. So fabric is able to rotate credentials on schedule or per session as needed on the various assets. And with the assets don't have credentials, I've mentioned that in the past, we're able to enforce access to those assets as well on per policy basis, utilizing the Xage enforcement point that's deployed in line, typically in front of switches. It's a hardware appliance that that works together with the fabric that to enforce granular access policies on layer 2 through layer 7. So you can create very granular policies. For example, you can indicate a remote user a policy for them to be able to access only a specific PLC or an RTU in the operational environment, and the fabric will relay proxy and control interactions down to that individual asset only. So Xage really shrinks and controls the potential attack surface through defined access policies. It really brings visibility and protection together. And with a reduced attack surface, the other big benefit is that it really focuses on threats. So I've mentioned this threat management aspect of the fabric earlier on this slide. What really the problem with today's threat management solutions is that there's so many interactions. That's a really noisy environment. So anything can potentially look like a threat. Once you shrink the attack surface and really control the interactions, now you can really focus on the threats that matter. Things like flooding attacks, spraying attacks, stolen credential use, or failed login attempts. We're able to bubble that up and point operators to realistic threats going on in their operations. And then it gives you also the controls to be able to mitigate and respond to those threats. Isolating an asset or isolating a specific user or even interaction is as simple as clicking a button in a central management, or automating it through our APIs.
Roman, what I thought, I'll just give you a bit of a few seconds to catch your breath. From what I see, the concept is very much about bringing this secure overlay across the existing network, which is good for both the IT side and the OT side. What I thought we might do is take a couple of questions now, if that's okay. John said, so I'm just looking through the Q&A, trying to find something that makes sense to discuss now. He says Zero Trust has been around for quite some time in the enterprise space, and indeed it has, but it's relatively new on the OT side. So you asked what's the what's the typical reaction? I guess also some of these things that seem to be quite complex. So what's the typical reaction when discussing zero trust in this industrial setting? Do people understand it? A lot we talked about before. I guess there's a lot of different stakeholders. How do they respond, and who sort of who gets it, and how do you bring people to the table?
Yeah, great question. I mean, I mentioned some of this with the survey that we've conducted. It's actually, the adoption of zero trust in the operational space, or I guess the embrace of zero trust is far ahead of what we even expected, right? The organizations are moving on a zero trust strategy. They have a plan in place, and many of them are actually executing on projects already. Many times when we interact with customers, we interact with many different types of roles within organizations. The CISO, the operation team itself, the plant managers, the cybersecurity folks. The understanding of zero trust varies per different role. Most of the time, the CISO office and has already embraced the zero trust strategy, and they're trying to work that through the rest of the organization. The OT cyber folks are also well aware of this, the zero trust approach, and are actually trying to figure out how that approach can map into their environments. It's a common misconception, and it's actually most of the education that we do is around this misconception that to adopt zero trust, you need to really re-architect everything. And that's a potential red flag for operations teams and plant managers that, wait a minute, we have to re-architect everything, flatten our networks, buy new equipment. Mm-hmm. And it's a big misconception. The zero trust can be delivered as an overlay. Certainly we figure out ways to enforce granular access per zero trust strategy to individual assets, PLCs and RTUs, without having to replace them, even assets that don't have credentials themselves. We can do so over a multi-layer cyber defense approach, a defense in depth approach. So Purdue model environments can continue to exist, and in fact, probably should continue to exist, providing defense and depth value, while also becoming a zero trust type of an environment. So there's a path forward there as well.
It makes sense. There's a flood of questions, and I do want to get on to the case studies, because as I said, I think that would be very one of the most interesting parts of the discussion. As I said, we'll try and save room for the questions at the end. Just one question, additional question that's come up a couple of times in slightly different variations. I hope I'm getting this right. Matt and Raul also asked, what's the difference between a remote and cloud user, and is the controller on premises or is it cloud-based?
Great question. So I'll answer the latter part first. So the controller is actually is distributed. So that's one of the benefits of the Xage fabric, is that the control can exist in the various environments at the edge in the enterprise itself, and operate independently. So at times remote sites can lose connectivity. And yet, there are people that go out there that interface with assets. So with distributed control, we're able to enforce interactions on that remote sites, even when it itself loses connectivity. So an experience of a local user accessing an asset on site or a remote user accessing that asset from remote location is the same exact experience. They go through the fabric. What's the difference between a remote user and cloud user? So with our solution, there's really no need for a VPN, right? You can, all the interactions happen through the Xage Fabric portal, which is a web-based portal where you can authenticate. You will see the assets you can interact with, and then you can access those assets through that portal directly. And I'm talking, various assets, including PLCs and RTUs. A remote user can access that portal through a cloud if it exists in that specific environment or in the enterprise itself. It just depends. We've had the whole solution can be deployed on premise in an enterprise, in a DMZ, or in operational sites. And it can also be deployed in the customer's cloud environment to facilitate interactions through that cloud environment as well.
Okay, perfect. I think maybe we should move on. So I'll let you get on to the case studies, and we'll try and save a little bit of time for the rest of the questions towards the end.
Sounds good. Okay, well, I'll just give you a quick, just 3 sentences on Xage itself. So we really founded Xage to focus on cybersecurity protection for these industrial operations. So when we founded Xage, we wanted to simplify the security stack, really the disjoint solutions that I talked about earlier, while simplify the security stack and also deliver comprehensive security in these very hard to secure environments. The Xage Fabric does that today. It delivers zero trust security for the real world, and we're currently operating and we're deployed in a number of various verticals, including energy, utilities, manufacturing, transportation, and defense. Let's jump onto the case study now. All right, so I'll take you through a couple case studies. The first one here is really a pipeline operator. This pipeline operator has really a pipeline that goes across the United States. It has over 500 sites across this pipeline, thousands of assets, more than 5,000 assets, and a variety of users that are interfacing with these assets. As you could probably imagine, such scale, they also have various types of networks that are connecting these sites, a combination of private networks, public networks, and other things. The specific pipeline operator, and as you know, many are today fall under the TSA security directives, which were released a couple of years ago now, and then been revised more recently, about a month ago. And these directives really focus on zoom in on protection for these pipeline operations, and this all happened after the Colonial Pipeline attack. And it requires a number of security measures focusing on access control, focusing on segmentation aspects like providing MFA and credential management for the various operational assets. The whole idea is to be able to protect those assets as well as mitigate and respond to when attacks do happen. So Xage, the challenges in this specific space were there are a number of types of assets deployed across these vast territories, legacy assets as well as newer assets. Passwords, there were various methods by which passwords were managed. Many of them didn't have passwords at all. There were limited ways to control interactions between users and actually vendors in this environment, both remote as well as local interactions. Really not a very consistent way of managing access. It's often shared credentials or just device-specific credentials were utilized from things like password managers. So what Xage did is we've deployed an identity-based solution that really provided a single sign-on experience for both employees as well as remote employees as well as contractors and vendors. We created an MFA overlay, so it's another requirement from TSA security directives is that all interactions must include multi-factor authentication, even for interactions with legacy assets like PLCs and RTUs that don't even have passwords yet. They need to be they need to have MFA interactions, MFA for those interactions as well. We've created granular policies that are used to control various interactions on site, across sites, in the field itself, as well as coming in remotely. The solution also created improved visibility. So identified all the various assets, the interactions those assets already are having, and created policies to limit those interactions, then flagging all the potential attack vectors that may exist. So interactions that are happening and that are violating policy itself. The other big challenge that we've solved here, and it's a common challenge across multiple similar operators and industrial space, is transferring of files and data. Many times you need to transfer files like PLC programs or patches into the operational environment, as well as extract logs or operational data from machines in the field. And this is very difficult because the concern is whether that operation is safe, right? Are those files, do those files contain malware, and just bringing in malware into the environment? As a result, different types of workflows, manual workflows, exist to do this in many operational environments. We've automated these workflows through the fabric. Each user and application gets a repository through which they can transfer files and data. And these files and this data is automatically scanned through malware scanners to ensure that it's malware free. So this creates this overlay endpoint protection scheme that ensures files are safe, data is safe, and also ensures that it's high integrity and authenticity, as well as controls to which machines it can be applied. So much more streamlined approach to data sharing in this environment.
So it seems like the initial sort of focus was on compliance. You talked about the TSA pipeline directive, and then it seemed very quickly, as we know, compliance is not security, but it seems like very quickly zeroed in on excuse the pun, zeroed in on some ways to reduce and mitigate some of those risks. I'm just very conscious for the time, so we've only got about 5 minutes left, and try and squeeze another question in at the end. But do you want to take us on to the next case study, Roman?
Yeah, I would just mention here as well that the compliance was a big objective, but also protection itself, right? And protecting the assets and reducing that attack surface, and really having the controls to respond to attack by isolating systems when they do happen, to see those attacks happening and then take control and isolate systems. Let me just jump to the next one here. The next case study is in the manufacturing space. This specific customer has manufacturing, actually steel manufacturing plants around South America, as North America, and many other parts of the world, where they've during the COVID times they had a significant increase in number of remote employees. Vendors could no longer come on site to troubleshoot either. The technologies that we're using in the past included, VPNs, and as I mentioned before, VPNs put users directly into networks and really introduced some attack vectors. They also did not allow for collaborating with vendors remotely in a really safe way. So the organization, or I guess some folks in the organization also started using tools like TeamViewer to allow for this collaboration with vendors to troubleshoot problems and address them in the fastest way possible. So as we know, TeamViewer is another tool that has introduced attacks or has become an attack vector. So they've decided to eliminate VPNs and eliminate tools like TeamViewer and really streamline remote access for their employees as well as vendors, and to be able to collaborate on projects. And that required access to workstations, to the various PLCs, HMIs in the environment. So what we did at Xage is we've deployed our fabric across about 10 plants that they have. It facilitates remote access without a VPN, provides, it has a built-in collaboration capability to be able to collaborate in real time with vendors, also to shadow what vendors are doing or what other technicians are doing, record all the various sessions for forensic analysis. And another big point here is to really authenticate the employees and remote vendors based on their true identity and layer on multi-factor authentication for all the various interactions. They've been successful just demonstrating maturity to the cybersecurity insurance companies that have been using. This is to your point, Jonathan, that you made earlier, and their premiums have actually been decreased because of that maturity. Specifically, things like MFA. If you can demonstrate that you've implemented MFA for all the various interactions, including to assets like PLCs, your impact on insurance premiums is pretty significant. Any questions around this, Jonathan?
Yeah, I'm just very conscious we're almost out of time. There was one question that came in around the insurance premiums, but I think you elaborated on that, and maybe we can do so a little bit more offline. I think there are, we won't get, unfortunately, to all the questions, but maybe one or two. One of the questions comes from, it says, does the platform support generation of risk posture reports, I guess reporting against some of those frameworks that we talked about before for some of the assets discovered? I guess that goes to how to provide some of that transparency. Is that something that you guys have seen the request and there's a solution in there?
Yeah, so there are reporting capability that's built into the product itself. There's formatted reports that can be printed out from the Xage Fabric, Xage Manager itself, and these reports have been used to satisfy requirements in many of our customers situations we, for example, dealt with requirements to satisfy a NERC SIP, to demonstrate the fact that credentials are being managed, that access is being managed, that strict rules, they're managed within certain timelines, that access is restricted on per policy basis for various users and their roles. Similarly for IEC 62443 requirements, these reports can be used to satisfy the compliance requirements there as well, or demonstrate maturity and implementation of the cyber processes.
Unfortunately, we seem to have run out of time, so we do have a number of questions still to be answered, and we'll take that offline. I'm sure Roman and his team can sort through those and get back to people and hold conversations if they're required as well. I just very quickly, some key takeaways. I think we can all agree that boards and management teams are taking more notice, right? There's more of a strategic focus. And this is the type of approach that can align with that risk mitigation and the strategy. Visibility we discussed, it's a great start. It's very important, but it's only a start. And in this particular case, and I know I get into trouble by generalizing, but the approach that we saw today around zero trust is really about providing this overlay that can enforce some of these basic and some more advanced cyber hygiene without having that rip and replace and without having to reconfigure things. And again, the market's maturing towards more proactive mitigation or taking steps to protect and not just to identify and to focus on visibility. So I think all in all, it's a very positive type of approach, and I hope people that participated would agree. So finally, I'd like to thank everyone, Xage, Industrial Cyber for hosting us, and thank you everybody for joining. As I said, if you have any questions, something comes to mind, please reach out. Thank you, Roman. Thank you, Xage, and thank you, Industrial Cyber. And again, thanks for coming.